there's no need to introduce also who are you, what Avail is. I think that's all there. I'll just quickly start on that front that you were in Polygon, you were in the research team, you were with them from the very beginning. Polygon is good and nice, and you had, as you mentioned, the co-contributors. What kind of evoked you to kind of build Avail? Is it like some specific problems you observe, or maybe you could have, I think you guys are initially building under Polygon or within a team, then you spun off. If you can tell us kind of what you separated that Avail with and the specific problems you observed, which Avail is trying to solve.
So, I mean, when I joined Polygon, they were already on mainnet. So they had done a ton of work. I would say one of the leading amount of work ever done by a scaling solution team that was already done there. So when I went in, I saw a team which is already star-studded. They understood the scaling problems. They already had something working in production, which at that point in time, I would say that there was no other credibly good scaling solution for Ethereum at that point in time. Now, after that, with scale came many different problems. When you run things at scale, like in 2020, 2021, we saw a huge amount of adoption of the Polygon POS chain. And when you started running blockchains at scale, you saw a lot of problems, starting from, just mempool getting clogged to, transaction propagation getting broken, to your get nodes not able to sync up, to, transaction gas just getting spiked up like crazy. You had EIP 1559 dynamics completely not working at Polygon POS scale, and so on and so forth, right? So there were a plethora of problems that we started facing, and I'm so happy and glad that I had been in the forefront of that scaling problem designing those solutions, right? So that is one part of my journey with Polygon. But the moment I joined, Polygon internally already had the multi-chain thesis, right? So if I don't think those early papers are still available on the Polygon website, but early Matic paper and such already had a multi-chain ecosystem world envisioned there. So at that point in time, Polygon took a major bet that they would want to go heavily into ZK, right? So they saw that the rollup centric design makes sense, that will be multiple chains and all of these will be rollups. And then they would want this to be validity proof driven and so on, not the optimistic one. This is 2020, 2021, I'm saying.
Okay.
Already back then, Polygon had already these visions internally laid out. And we realized that DA is going to be the ultimate bottleneck. When you go to the rollup centric world, you could already face DA. Let me flip it. And you might say that why is DA such a thing in 2020? In 2020, Polygon came up with a hybrid chain design. They had a plasma and a POS. So the same chain used POS, but also you could deploy plasma contracts. In the plasma layer, when we were designing those contracts, we saw the problems of plasma, and we saw the DA challenge thing head on, right? So when we saw the plasma couldn't survive, at those point in time, we had to scrap plasma. Although the plasma tech at that point was very hyped up, but by 2021 we realized that it is going to be very, very crazy to maintain this plasma, because maintaining them, writing them were going to be a big pain. So completely switched to POS. But DA came to the forefront of what the problems that we needed to solve. In 2020, when I joined, one of my interview with Anurag was on DA. And at that point in time, it was very nascent. But the moment I had worked on data storage, retrieval, proofs of availability and such, but when I saw that what data availability can mean in the blockchain context, it completely opened up my eyes. So within Polygon, we worked on scaling solutions and the POS chains and the problems of that. We worked on ZK rollups, but we also kept working on Avail. That is the DA side of things, right? Now, while developing all of this, we realized that this DA solution should not be, enclosed only for the Polygon ecosystem. That it should be credibly neutral. if a DA is not neutral, it cannot do a lot of the work that it can do when it is the base layer for multiple different rollups. We didn't want Avail to be Polygon Avail, right? So we wanted Avail to be a neutral platform, which is ZK Sync, a Starkware, a Polygon, an Arbitrum, an Optimism, and a Sovereign, and a Stacker, and my own rollup company can also use, right? So we wanted it to be absolutely credibly neutral, which multiple rollup stacks can use, because we do not want more silos. And that is from where we spun off Avail and we started creating Avail. But the original vision remained, that is, we want to create the base infra for a rollup centric world. And while DA was the bottleneck that we solved at that point in time, today it's more about fragmentation, right? So if you think about the problems today, the rollups have a huge problem in onboarding the first user, regularly onboarding and offboarding users, and getting enough economic traction to make sure that their rollups are significant in this competitive space. So that's why we are coming up with those Nexus upgrade and the Fusion upgrade, which is making sure that the Avail DA stack becomes more feature complete, to be enabling any rollup, no matter their size and scale, to come and have abundant scale, have abundant economic security, and have the interoperability and seamless interconnectivity with other chains. So that's roughly Avail.
I think if I got it correctly, I think the DA was the first problem you solved there, and that kind of helped you spun off Avail from Polygon. And now, as he was mentioning, and there are like Fusion and other stuff, but I think one roadmap is kind of solving the interop problem. One is, I think it's relatively new, the shared security. We'll come on to that. But I think if we let's say start with DA, right? And I think we just was talking about it before recording it officially, about the difference with EigenDA. Specifically mentioning EigenDA because, again, coordinated EigenLayer community media and all. So like I have seen you like talking about, okay, EigenDA has taken a different trade-off, and EigenDA is not a blockchain, they don't have consensus, but Avail is a blockchain and it has different way to kind of solve the DA challenges. I like you to kind of highlight both the pros and cons, because what EigenDA is providing very high TPS, obviously because they don't have blockchain, there is no node redundancy, which Avail has to make sure it's all the nodes are communicating and stuff. Want to know, like, in a not very detailed but slightly, what are the architectural difference what EigenDA and AvailDA has taken, and what are the pros and cons of both? Like, where can EigenDA excel or where can AvailDA excel, if you can?
Yeah, I think I will take a very biased take here. Please do your own research and cut out all the bullshit that I spill right now. Largely speaking, it's about how effective a committee can be versus how effective a full-blown consensus design can be. Now, let's talk about a particular use case. Let's talk about, I have a ZK rollup and I have a sequencer-based ZK rollup, right? So now the sequencer takes all the transactional data. It now sends it to a DA layer for just making sure the data is available, right? In an EigenDA sense, it will send it to, I'm forgetting the name of the disburser, probably, which is a centralized entity which will send to multiple different committee members some shards, right? So small parts of it. They will all sign it. If there are enough signatures, you would say that it is available. Why it is available? Because the disperser first takes the data, it erasure codes it, or basically creates redundant data chunks. It then sends this to the committee members. If some k out of n of the committee members are honest, you would know that the data is still reconstructible and hence that the data is available and so on. So, right? And then all the signatures is great, but what is the verifiability? What you do is you take those signatures, you put it in a smart contract. This smart contract verifies those signatures. The smart contract verifies that there are enough signatures and so on. So you get the economic guarantee that if one of the signed members are not able to provide the data, then you can slash them and so on, right? So this is EigenDA to the best of my understanding. Please don't believe what I said. Maybe I missed many different parts. Now, the thing is that we believe that there are two critical aspects that a DA layer needs to provide. The one critical aspect is ordering. If a DA cannot provide ordering, then it cannot be the source of truth. That is our belief. What do I mean by that? What I mean by that is, suppose me and you are both running a based rollup, or forget a based rollup, even a sequential based rollup, right? Now, both of us submit data and we want to interop between us. When we go ahead with those ordering kind of guarantees, we need to know who came first, what transactions of what rollup came first. So who decides on that ordering? Someone needs to do that ordering guarantee, and that is where the DA ordering can come into the focus. If this was a debate, I am very sure someone else would have come and said, like, today there is no need for that. If you want that, you go to a shared sequencer. Why are you talking about the DA layer? The reality is that when we do this at scale, when there are hundreds of different rollups which are all publishing data and getting ordering guarantees between one another, it will be almost impossible to run shared sequencers at scale, or making sure that the relative ordering is guaranteed by a committee member, right? So that is where we wanted always to have ordering and DA guarantees. So if you read most of our stuff, we keep on talking about ordering, right? Because ordering is extremely important to the overall thesis of what we are building. So that is part one. Again, pure trade-off. I'm not saying that getting ordering is fundamental or it's a deal breaker. Maybe not, because sequencers are giving ordering. In based rollups is definitely a killer thing not to have ordering. The second is, yes, you have this committee settling onto Ethereum, but what if I want to make a non-Ethereum rollup, right? I mean, I might want to, rollups are not just, native to Ethereum, so, right? So we have Bitcoin rollups, we have, Solana rollups coming up, we have L-Force and, random layered constructs which are coming up on Avail. And we want to give them also the same amount of security guarantees and such, right? So by making the committee settle to Ethereum, you only get the economic guarantee that is only captured on that Ethereum contract, but nothing beyond, right? While having a full-blown POS chain gives you far greater guarantees irrespective of where you settle, right? So that's the second trade-off here. The third is, we fully rely on a light client for availability. We do not want to believe that even the Avail chain will be always super honest. Of course, we would want it to be, but there might be times when even the Avail chain can start behaving in random ways. So it might claim that something is available, but if you do not have verifiability on top, so if there is not a light client which can, if my mobile phone cannot ascertain whether the data is available or not by sampling it themselves, then I do not think we have done the full mile job, right? So that's why we go that extra mile. We say that these light clients form an overlay peer-to-peer network, and on this peer-to-peer network, the data remains available. So think of it like, maybe this is a very bad example, but I publish a file on torrent, and even if the initial uploader now starts censoring, because you have uploaded to torrent and many people have downloaded it, you still will be able to download that file. That is the power of P2P systems that a single committee cannot, right? I mean, think about it. If I upload to any storage provider, any centralized storage provider, it's not like they have a single server, right? They have a distributed system of servers that all collectively say that yes, this file is available. But when they start censoring, the committee collectively starts censoring, that distributed system collectively starts censoring. But that is when the peer-to-peer systems are so much harder to censor, because the data becomes available there. So that is the final mile that we go, and we feel like that is the killer feature that is needed to make sure that not only DA is accessible, but also it is verifiably accessible to everyone. Not just verifying signatures, but by sampling and asserting the DA guarantees ourselves on our simple Raspberry Pi.
Awesome. I think the way you explained, I think this might be one of the best explanations available for how Avail is kind of different than others. I can again draw to Celestia's way and all, but I think it will be very big discussion. We'll now stick to like Avail's core propositions. I think as we were discussing, DA is one, which you this went in pretty detail and how it kind of differentiates and all the advantages it's provide. Second is, I think, the interop, right? I'm forgetting the name.
Nexus.
Nexus. I think that's like, I think, pretty good amount of research and blogs have been put out that how Nexus is kind of helping solving, like making the unification layer happen. Want to know that how kind of the DA part is like adding up, and what are the, like, what's your goal with Nexus? The reason of asking this question is that there are so many projects out there who are telling that, hey, we are solving interop and all. We know there is a definite fragmentation problem if all the chains don't seamlessly communicate. It's like you having a Gmail, but you can't send a mail to Outlook. It doesn't make any sense. So, like, what's the way you are thinking to kind of solve the interop problem? And since DA is the kind of it's the core where Avail pops up, how the DA is kind of facilitating the interop thing.
So essentially, if you like, why, I think you asked a very pertinent question about why interop, right? Why Avail needs to solve interop, right? There are so many interop players and all of them are fantastic, by the way. Like, we do not want to go out and say that any one of them are not doing a job good enough and that's why we are having to do. It's not the case. I think to answer you straight on, I have to go a step back and say, like, if you have a rollup, you want to know that the execution correctness of that rollup. You need two things to know that. One is that you need to know that the execution was done correctly. And the second, on what was the execution done correctly, right? Think about it. I give you a addition, right? You to know that the final sum is correct, you need to know not only that the addition was done correctly, but you also need to know that the arguments are also available and they were correct, right? A ZK proof only gives you the guarantee that the addition was done correctly. I can give you a ZK proof that the sum is 5. You wouldn't know whether it's a 2 plus 2 is 5 or
1 plus 1, yeah.
or 1 plus, because I will give you a proof of 3 plus 2, right? But if I change my arguments later, right, it completely falls apart. So that's, again, bad analogy. I will probably get a lot of slack for oversimplifying this, but you need to know that the data is available, that the transaction data over which the ZK proof is constructed is correct, and you want to know that the data is available and that the execution was done correctly. So these are the two things that you need. Now, coming to the context of cross rollup interoperability. So you have two rollups. I have a rollup, you have a rollup, and we want to communicate. The moment we want to communicate, I need to verify both of your properties, that the execution was done correctly and the data is available, and you need to do the same. Now, when we have the common DA layer, one of the problems just goes away. Because we have a shared DA layer, your guarantees of data availability are already intact, because we have a common DA layer and the common ordering and a common consensus engine, right? So already we have a shared security, so to say, in some sense, right?
So let's say they roll up A and roll up B. Roll up A posts its data to the DA layer.
Yes.
Roll up B can also fetch it.
Exactly. So you do not need to again check the DA guarantees of that rollup. All you need to check is the execution guarantees, and execution guarantee verification is extremely simple, right? Let me give you a different example. Let's say that I want to talk between one Cosmos chain and an Ethereum, for example. So what does Ethereum need to verify? Ethereum needs to verify that the Cosmos chain, all the validators of the Cosmos chain already agreed on an ordering, and on that ordering, what is the assertion of the state, right? So you need the full validator guarantees to be verified inside Ethereum for the Cosmos chain to talk to Ethereum, right? The same with rollups. If you had to do it with cross DA, you needed to verify the entire DA assertion from a validator set or EigenDA committee or whatever, right? So this is where inter-rollup communication gets much more secure when you have, common DA layers. And this is why we are trying to solve the interop problem between this ecosystem first. Now, it is not that you cannot communicate with other chains, right? So it's not that a lens cannot communicate with a base. They can still do it, not a problem. The guarantees are different, the security guarantees are different, and that's where we are already using existing partner interop solutions, right? So we are not saying that we are trying to do it from grounds up. No, that's not the point. The point is, wherever there is a possibility to have a better security guarantee, we will use ZK proofs, we will use TE proofs, we will use optimistic guarantees to provide better security for cross rollup communication. And wherever it's not possible, we will fall back to existing bridges because they are the status quo, they are the cutting edge right now. So that is the reason why we are solving the interop.
Awesome. I think just you also mentioned about the term shared security. I think if I'm not wrong, EigenLayer came up with this, like about this shared security, taking Ethereum's security layer, giving it to like anybody can use that security, design slashing mechanisms and do bunch of other stuffs. Want to know about like the design of Avail's shared security? What I've read is I think there is like multi-chain, like multi-token security can provide, be it ETH, BTC or others. Want to know like the design trade-offs of Avail there and like how like the protocols are using, or if it's not live yet, what's the plan of use this shared security layer?
Yeah, I think shared security is a much discussed concept from a long back, right? So, of course, EigenLayer has done a fantastic job of rekindling that discourse. But it was always the dream that you will have one shared security infrastructure, and around it which there will be multiple of these chains. I mean, Polkadot had this exact same discussion maybe around 2021, 22 or something like that. So coming to what exactly Avail is trying to provide, right? So the gist of it is that we want Avail's consensus to be not only limited to the Avail token, but we want other tokens to also contribute to the economic guarantee that Avail provides. Now think about it, that a rollup is depending on Avail DA for its economic guarantees, right? So we want to amplify those economic guarantees, and that is the reason why we want to provide not only the Avail token, but we want to also provide, let's say, a BTC and a ETH. And then we want to also make sure that the rollup tokens also have to play a role there. But that's not where it stops. This is only part one of the problem, which is how do we make Avail's economic guarantees much bigger? That's point one. But the point two is, and this is something that we are actively seeing right now, is that rollups themselves are being judged by their TVL, are being judged by how much of economic activity are they securing, how much of funds are they securing and such. So we want to utilize this economic guarantee in order to provide some bootstrapping of economic security to these rollups, so that these rollups can get that economic activity started, can get this these kind of economic guarantees inside that rollup, and can get that TVL and the inflow of funds and get that ecosystem running, right? So that is essentially what we are trying to do. Now coming to the specifics of how exactly this economic security is going to come, there are a plethora of ways, right? So one of them is, for example, we are talking to a few other ecosystems, and they are willing to provide direct economic security on Avail, right? So that's one. But then we can also go to the risk-taking primitive, something that EigenLayer and Symbiotic and others are leading, and we can take economic guarantees from there, right? So we can borrow economic security from there. So that's also another way that we want to bootstrap economic security there. And largely what that enables is that, again, it comes back to the flavor of shared security. You still have, if you have this common, hugely secure, economically slashable DA layer, where all these tokens are baked into the consensus. It's not like, it's an out of protocol thing. We are, the Fusion prototype that we have is completely slashing ETH and a Solana and any other token that is coming to the base layer. We want to make all of them slashable. We want to make sure that every staker has the ability to stake not only Avail but also other tokens that we enable.
I think all this, the thing we discussed in terms of the Avails, like roadmap or architectural thing, be it the DA, the interop, and the shared security, I think it aligns with the main thesis, like unifying Web3. And that's what kind of is the marketing communication. I think all these things, if they are like stayed together, I think it can solve that interop problem. I think like we can go in detailed discussion how to kind of get out of that Avail ecosystem and kind of talk with the other like crypto protocols and all. But I think let's park it for some other time because that's very detailed and all.
Yeah, I would just want to say that although we want to be very, very clear that it is not a Avail ecosystem only thing. Like, I think we have enough of these. Like, there is Superchain from Optimism, then there is Polygon is handled as AgLayer, right? But whereas they also talk about different ones. Elastic Chains by ZK Singh, that is Arbitrum is the only ones probably who are not talking about only their ecosystem, right? But I think we have enough of these. We don't want to create another silo. That is completely beyond of what we think. What we think is that we want to create the base layer for horizontal scalable chains. What it means is that today, when you come and interact with Instagram or Amazon or any of the Web2 services, you do not know how many servers they are running. You do not care. And similarly, tomorrow when you come and talk to an application, you would not realize that they are running a single rollup or multiple rollups behind and how they are communicating. All you will get is one monolithic experience where you come to this application, you go to the lens, you use Hey, and you go to Hey, you post, you read others' post. You don't care, right? What kind of rollups given behind, how are you reading that data, what storage provider are they using, and so on. These should not be the ones which the end user should care about. And that is the fundamental technology why we are building all of this. We do not want the end user to know all the gory details. All they care is, I want to go to Sophon, I want to, buy something. And when I buy it, even if my funds are on Base or on Arbitrum or Ethereum, on Solana or something else, I should be able to seamlessly, I could see like, okay, I have funds here, I will bridge from here and so on. Within a few clicks, it should be done. And that's what we are preparing for.
Awesome. I think that's like many founders like which I'm talking to, they have a similar vision. I think many are also seeing that it's best to kind of abstract the blockchain layer problems so that app developers can focus on the application logic. And let's say with a few APIs or a few library calls, all this blockchain complexities are taken care of. I think I'll come to a little bit on the app side of Avail. Like obviously, you being an infra developer or protocol founder, I'll say you have much bigger vision or you have much clear thought process on what can be done, because nothing against kind of mentioning Solana, but it's fine. I think with the firm.fun kind of stuff or even poly market and all, although people say it's a prediction market and all, but I personally feel it's good, but it's not that app which like my mom or like a very like my aunt will use, right? And I think app developers can think like, as I was telling, that okay, if we abstract the blockchain layer, there is this founder centric people are seeing, okay, we have this blockchain, we have security, we have this distributed system, and we can build stuff. But it's want to know from you, if you can share a few instances you have thought, like what are the new apps which are possible on crypto rails that can actually bring value, but out of speculation or out of payments, which crypto is very popular for.
I think the problem, again, I will answer you head on. But before that, I want to just say that we keep on thinking that we have this, blockchain as a token, and this tokens where can be transferred from one to another. And on top of that, we have the smart contract layer, and the smart contract, you can encode some logic, and this is your tooling. What can you build on top, and what are the applications can you build on top given these primitives? I think we need to spin that out. We need to talk about, how everything in the technology space is interaction between different people, and what kind of guarantees can they get by using blockchains, right? So blockchains, as you are rightly saying, they should be just primitives, right? So for example, let's take I mean, yes, AI is a big thing right now, right? So people are just talking about how new models are getting built, how many parameters can you fit, and so on. But we need to think, okay, there is an AI model, there is a big company which is doing this, and they have given a ton of work to make sure that that happens. But how can I make it verifiable? One of the biggest reasons why anyone should use blockchains even is because it provides verifiable interactions, right? And I personally am here because of its verification properties, because of its censorship resistance properties, and because it can be, non-centralized in its stake. What rollups are doing is that they are saying, even if you are a server, you have a verifiable server, right? And that's a big unlock from existing blockchains where, 2 years back, everything was an L1. Today, not everything is an L1. And that's a big unlock because you can have verifiable servers. Think about, even if this is a single server, I run a DeepSeek in my local server. You give me a query, I run it by it and just give it to you. How do you know which model ran, whether the output is coming from it, or I am, writing it up and just sending it to you, right? So that is, if you think of it as a verification problem, then you will see that blockchains are a perfect fit. I do not need to rethink about my smart contract logic. No, this is a verification problem. Now I would say, okay, how do I give this verification guarantee, right? And that's when you can have a ZK or an MPC or a, shared security, smart contract, RISC-V, EVM,
FHE.
SBAVM, FHE, whatever. And those are just primitives. You do not need to think about. One of the best things that has happened since the time I joined to now is like people are not talking only about primitives. Previously, people used to talk about, oh, I am building this FHE platform. Like people now talk about applications, and that's great because that is what is needed. All the time that we discussed, we didn't talk about KZG. If it was 3 years back, we would have only talked about KZG and
Unsure coding and all this.
Exactly, right? So those are the kind of things that the crypto industry is seeing a change. So again, I gave one example. Now coming back to your question, I don't want to evade the question. So that's one. The second is, if you think about ledgers, like general ledgers, if you think any company maintains a ledger, the problem is that there are billion-dollar companies just providing ledger as a service. And ledgers are the default entities of blockchains. Blockchains are nothing but distributed verifiable ledgers, right? So every company out there is already using a ledger, so why can't they use a rollup, right? Now by making it a rollup, I'm not saying like they have to use Across as a bridge. No, they can just use the best-in-class ledger that technology has to provide today, right? And this ledger has double entry protection, something which is a core feature of a ledger service company, which comes by default in blockchains. You cannot do double entries, right? So if you have ledger as a service, then why can't you use that as just a blockchain primitive? Your blockchain is not important. It's just an entry mechanism, right? Third, like I want to like custody, right? I mean, conditional payments. Again, you explicitly mentioned not to mention payments, but I feel like I'm not talking about just peer-to-peer payments. I'm saying like conditional triggers, custody of payments. These are very hard. There is a problem. There is a open, like unsolved problem, which is a two-party fairness, right? So basically, one of the first times I came into the blockchain space, one of my first kind of papers were about, we both want to exchange something and we want to do it fairly. That is, if you give me the thing, I would give you the money, and vice versa. The problem is in two-party systems, this is impossible. If you give me the thing first, I might not give you the money and I can run. And if I give you the money first, you might not give me the thing and run. One of the best solutions there is to take that item, break it into pieces, take the money, break it into coins, and you give me one piece, I give you one coin. You give me one. This is called iterative fair exchange mechanism. These kind of things are almost impossible, although so prevalent in existing systems that you need to have third-party entities just to act as middlemen. Right? You both of them pay this entity just to make sure that you give it to this guy, I give it to this guy does it correctly, and then sends the money to you, item to me, because this guy is a credible middle party. These kind of interactions have been completely obliterated because of blockchains, because blockchains are the trusted third party. They are the censorship resistant, they are the immutable, they are the compromisable kind of middleman that is out there. So why don't we use blockchains for those contexts, right? So you see, like I'm trying to say it a bit differently, right? You do not need to bring Web 2 to Web 3. That's the wrong approach. The approach is we make Web 3 so primitive based, API based, that I can take these Web 3 primitives and an existing Web 2 stack, I can plug it in. Now, whether these Web 2 systems will talk to each other, they will anyways talk to each other. In Web 2, there is nothing called not talking to each other.
They're interoperable.
Exactly. They're by default interoperable. Then you realize that how far we are behind to talk to one system to another. And that's why you will feel like, okay, interop has to be a given. Shared security have to be given. Because there is nothing there which is they cannot imagine a world where you cannot trust another party. Okay? Here we want to not trust but verify. That's the added primitive. That's why we are building this entire system and the body of work that we are doing.
Awesome. I think it is awesome talking with you. I think the kind of insights and information you have and the kind of depth you have, we can like talk for hours for sure. But let's keep it for the first interaction like this, and we'll surely like to host you again. Yeah.
Awesome. And thanks for having me. Thanks the team for coming over during a busy week, and thanks for spending the time. It was lovely chatting.
Awesome.